So thank you very much. Some of you I know I've seen before, and I'll try and make sure I do this properly. So this is me. I've been doing things for quite a long time, almost 40 years. I'm a security expert. 2000 sort of exploits and things. We do the automotive industry, and I'll talk to you about a program called RESAuto. Whilst attempting not to talk about exactly the same things as Hardeep or anything of that nature, we do cover various different representatives as we go through that. Our partners on this are Warwick, but it's primarily driven by Thales, and we also partner with ASIN TechWorks, who are our group that are actually looked to get influence on a worldwide basis for economic, for chips and things going into that. I won't stay any longer on that one. So RESAuto, we set out to demonstrate, this is our manifest, digitally secure by designing complex interconnected systems, which are subject. So whilst we do the automotive industry, we also have the advantage that we can talk about ships, trains, planes. Yeah, we can talk about all sorts of places that people care about things, UAVs, drones, because we have all of those. And at the bottom level, we actually do supply things like various AutoSAR capabilities. We supply various operating systems. We even do chips in various places. We do quite a lot in relation to those sorts of things. And we look at the conflicting through life objectives for safety, privacy, and access to various things. So other elements that are in there. Most critically, we have access to data points that are allowing numeric corroboration of potential impacts of Cherry-based solutions. So it's been really interesting, and personally, I'm a fan of Cherry. I like to listen to all of these things. But as Hardeep was starting to get onto there, if I can't show the money, then I don't actually get traction on these things. So trying to get to a way of doing those sorts of things. And the reason that we chose the automotive industry, and you may have been seeing some of this in the press, is because starting last year and going into this year, you can't bring a car to market unless you have a through life cyber plan lasting for 8 years that covers both the on-vehicle and the off-vehicle aspects of that. And what does it mean to have a plan? It doesn't mean that I went, thank you very much, I've got a plan. It actually means you've got a costed plan, including what did you plan that you were going to do yourself? How much money did you allocate for it, and why was it justifiable? But also, how much am I insuring against that in case it all goes wrong? Some of you may have seen that VW withdrew the e-up, which was their biggest selling car, with a full order book because they couldn't do the cyber security on it. Porsche withdrew the Taycan just before they brought it to market. The last two Minis were not brought to market. So you're actually getting to a situation where cybersecurity is actually a major impediment to being able to bring things. I could cross over into the aircraft industry and observe that the US has stopped doing the F-22. This is a major issue in relation to that. So you would hope that Cherry might have some opportunity to fix that, and actually we could demonstrate that because we'd be able to do things at lower cost, and we'd be able to bring more products to market and that kind of stuff. So we have access both to the costs and to the actuarial tables in the insurance industry on which they're basing these sorts of things. So I like golden threads that go, if I do this, I'll be better off. So I don't really talk about security. What I talk about is how it has manifested itself in some impactful way. And we've been talking to various things. So there was a question there about what OEMs and people. So we talked to Continental, we talked to ZF, we talked to various others, we talked to Geely, we talked to Ford, we talked to JLR. We're in bed with Renault and that group, Stellantis. So we talked to a good cross section, and I think we're expecting to be talking to the Hyundai group as well in the near future around these sorts of things. That essentially cross from Asian manufacturers through the small volume manufacturers we have in the UK, through the Germans and the US. So we get a good representative cross sample of people in relation to this, and that was what we have set out to do. So this is us. We look at the economic benefits and disbenefits. Somebody challenged me about whether that's a word, but it's in the Oxford Dictionary, so I'm okay. I guess Oxford Dictionary here, that's no good, is it? Whether the of the cherry-based approach to engineering and other regulated industries, because these are becoming important. We looked at things like the implications for skills. So there's a really good thing if I can basically use idiots to write the things that are going into my containers. Yeah, that will start to address some of the skill shortage that people have as we're moving into a lot more software-defined elements. Power consumption, that was a really big thing. So if you look at the power electronics elements that the UK is concentrating on, we're hoping to be able to get 10% more range on a car because we do use the right sort of chips and things to do that sort of stuff. How does it fit into that? Safety criticality, and you had some summary there of some of the things. And we also looked at complex supply chains. So one of our observations here was that we talk about security as though that manifests itself in the same way for everybody. And let me tell you, that's not the case. So we looked at things like IP suppliers, so chip suppliers, people who do various components down at the bottom end of this one. We looked at product suppliers, so the tier ones and the things in relation to that, people who do a braking system or a component of some sort in relation to that, and the system integrators, so the OEMs at the top level. And I'll come back to some of those things because part of what we've been finding is that things don't fit in the same way. People don't see benefits in the same way across each of these things. And if we don't fix that, it makes it very difficult to get a proper pull through for some of these benefits. And we end up having done a fantastic solution that nobody wants or is not as exciting as it should be to some of the people that are in the chain. We also almost ignored the consumers because I very seldom go into the car showroom and ask about Cherry. I find I don't have that kind of influence. So it tends to be that you need to get the right people in there. And why auto? As I say, because it's costed and monitored through life on and off vehicle. And they are working now to actually understand all of those elements as they go through. And to put that into context, our conversations with VW went, so you're telling me I have to maintain 3 code bases and put those through cybersecurity? Not a chance. That was their big thing here. Unless I can find a way by which we can actually keep this at roughly the same sorts of costs, I don't have an option to do that kind of thing. I can't become 3 times more expensive for my cybersecurity, even for an 8-year period of time, because I'll be out of business. So those were interesting. So, and as I said, the unaffordability of cyber was a major thing. Just to give you some framing remarks here, I do put these things up here. We've noted that everything's joined together when we talk about complex systems. Yet how things fit together is one of the things that the automotive industry has discovered, as in they have a very complex system now. So currently 155 ECUs, but they're trying to combine that down into a lot fewer. But that includes lots of sensors, lots of other things. The real thing that I wanted to show was this graph over in the far bit there, which essentially was the thing in relation to IoT that came out in 22. Staggeringly, the top 4 categories have all got safety of life implications of one sort or another, and they are all bigger than consumer electronics. So there's an argument that we've actually been concentrating in the wrong place on a lot of the things that we're looking at. There's a lot more importance in these things, and we are starting to discover that it matters, and we're going to kill people with the things that we're doing, or at least we're going to create harm, which is why that's moved into the government's vocabulary about what they're about what they're talking about. And these were my framing remarks. This is what I look at when I look at automotive or anything else in that kind of thing. I look at a complex, hyper-connected, bottom-up system with emergent properties for which there's no guiding mind. So the fact that I get to fix a particular component of it has to somehow ripple through into that. It benefits at scale, all these sorts of things. I'm not going to read my way through these things. The point about this is chaos and emergence are the characteristics of this. And in that context, I have to find a good, real reason why Cherry is going to be something that I can actually I can monetize. So is it going to allow me to do these sorts of things as we go forward? And I look for resilience. Apologies here. It says I'm a security professional, but this bit about this thing that we actually always describe mechanisms, and the danger is we describe the mechanisms of how things work, but we don't actually communicate why that would make a difference to any of the things we're actually trying to put it into. So this is my gate in Ashdown Forest. It has no fence around it. It's stupendously useless for anything you might really want a gate for, but it's a good gate. So if you tell me I've got memory safety, tell me how that makes a difference in relation to these things. And I'll come back in a moment to what we've done in order to try and look at some of those elements. The one in the middle here is a single point error on a machine learning algorithm in a sensor, which is actually causing more problems than memory errors in the sensors at the moment. That's causing me to actually get misreadings. It's causing the system to misunderstand what's going on in relation to that. So that's a really big deal, because the way in which you get fidelity and you get your sensors to be as effective as you can is that essentially you don't look at the raw data that comes out of them, you turn it into something that you've guessed about with your machine learning. So that's sensors that we have in relation to that. And the other one that I think we should think about when we're talking about cherry-based systems is when we make something strong, we make it brittle. So there's a number of different attacks that we've started to be able to do because we've hardened the architecture. So essentially, it's now much easier for my attacker to predictively do memory-based things on the basis that you're now trapping them. So I can basically trigger that when I want to. That's really difficult in the context of safety systems, because it's made it much harder for me to do a probability-based distribution in relation to that. And Hardeep's thing, where he's got that ridiculously complex graph of how things, that's what people have to go. So I will tell you that we have brought on, as part of this, people who are responsible for legally signing their name on the bottom, and their starting position was over my dead body. Am I using anything like that? But when we calmed them down and explained all the things, there are good points. I mean, there are many good points about what they would want and the determinism, but their point is it needs to fit into a mechanism by which you can take evidence to court, by which you can do the sorts of things that you need to in relation to that. I'm on my hurry up, so that's good. We've also observed, it was somebody that slapped us around the face and said if memory was that important, we'd all be using Ada by now. So it's not that it's not important, it is important. It's just that other features of our systems have turned out to be more important than that in the things that we're looking at. And those, I think, are the really important things. Making that balance and being able to make that argument about how those things fit together has turned out to be an important aspect. We spent some time looking at the law. I don't know why. People say you should do multidisciplinary things, and I didn't think anybody else would talk about it, so here you go. And observing that in an automotive context, you get parallel things that you're actually having to talk about. So when you talk about cybersecurity, we talk about this in terms of technical things. But when I go to a board of directors, they talk about this in terms of what are they legally responsible for. And they are legally responsible if you're an OEM for crashing the car. That's criminal responsibilities. You don't get to contract out for that responsibility. If you're talking about product suppliers, it's normally contract. So it's essentially I'm trying to make sure that I'm not liable for more than this amount of cash when things go into place. And that's important because in the supply chains as they go through, you've got different organizations with different incentives and different things going through. And if we're going to make Cherry be successful, we have to work out how that works through each of those different gaps. And it's not an easy thing to do in relation to that. So I invite you to consider as you go through this, that the people who are doing the products, so the tier ones, will be looking to make sure, as you have seen with Tesla and people, that they are not responsible for the outcome. And they'll be restricting that to a cash settlement. The people at the other end have a thing called what's called strict liability. They'll be in a position in which they're taking responsibility for the outcomes that come from this. Yeah. And it may well be that people who are actually going, I can now deterministically tell you when it's going to stop or not stop, are very handy if you're in a product supply capability. And there's really bad news if you're talking about trying to actually go to court with something that's crashed. So imagine that your automatic lane keeping assist system stops, doesn't do what it's supposed to, it just stops. That is a really bad news for somebody. It's even worse if you're talking about planes and things of this nature. So those are the sorts of things that you need to look at. What have we used to get our data points? We've used 400 plus person years and 2.5 million lines of code to actually go through and look at how would we do Cherry. And I have to tell you, we found it really interesting to look at this. We did not find memory errors largely. We've managed to find 4 in that base. 2 of them are in test routines where it was deliberate, because you have to stimulate certain types of memory errors in order to test your behavior. But the other 2 have come out of automatic code generators. So that was an observation that often people are not actually coding. They're taking things through UML or something of that nature because it's a distributed system and they expect to target that down to multiple processors, because otherwise getting the coordination by humans is a really big problem around those sorts of things. On there, we've managed to find 2 errors and we can't explain them at the moment, I have to say. They don't seem to generate errors. But Cherry has told me that, so we'll stick with this because we're sure there must be something there that is genuinely, but we can't find what it is at the moment. But that's important because I had hoped to reduce the skills and not have to actually get my most skilled people trying to figure out what the heck had happened here. But that's the outcome we had. The other thing, it's been commented a couple of times, that if you want to get this stuff in there, you got to get it into the standards. This 500 plus years of code is written using MISRA C, Insert C, and things of this nature, which are designed to try and make sure that we essentially code in such a way that we are coding in to avoid memory errors. So I don't want to say it's memory safe because you can still get around those sorts of things and you still get other things at runtime that are actually causing a problem. And we've looked at regulated industries, which include telecoms, finance, transport, aerospace, space and defense. We looked at space particularly because the possibility of memory errors in space was potentially interesting. And we've put a set of initial economic hypotheses around this where we have suggested these would be useful. And that's included running things in simulations, because then I don't have to take the negative consequences at the same time as the positive ones. Those, I think, would be a useful way of getting things in there. On the metrication, we've got access to the metrication and the anticipated cyber costs. At the moment, with the best that we've been able to do, we've seen a 50% to, or 25% to 50% increase in the cost of the cyber by putting in a Cherry-based solution. We'll keep working on that, but that isn't clearly going to be an outcome that will attract people to using these things. So we've actually set out to measure those things and make sure that we can see where we want to be and how we put things through in relation to that. On the supply chain, we've looked at some of the consequences over the past for things like Spectre and Meltdown, which you may or may not remember. These are hardware-based errors and things of this nature. None of these were really memory errors in relation to that. So when you talk in terms of supply chains, one of the interesting components here, it took about 10 days to get a fix for Spectre and Meltdown. The automotive industry are still working to try and implement that fix into their vehicles. And why would that be? Well, the reason for that is because if you take 25% of the cycles away, what is not running in the 25% of the cycles that you just removed? They are agonizing now over the consequences of things like the European cyber directives, where their supply chain is starting to be obligated to change chips and things underneath them. That is far more of a problem to them at the moment in terms of cyber than the memory errors. And that maybe shouldn't be the case, but it certainly is the case. So again, here looking at the things, so integrity, availability are some of the really big aspects that they're looking for. So that availability element and how many cycles is also what's actually giving pain in relation to the, it's also what's giving pain in relation to the use of containers and things. Yeah, so the ability to actually lose capability. So we think in terms of IT and data flows, they think in terms of cycles they don't have available. And we have to find ways to address talking to them about those sorts of things in order to have something that actually matters in the way that I hope it's going to matter in relation to this. So these again were just examples of what we've seen in terms of hardware problems over the last few years. Yeah, and you'll appreciate that they have many other things on their plate, and when we rock up and tell them it's just this one thing, it has to fit into all of those elements in relation to that. These are my last two slides. So these were some of the questions that we've been asking. Can the Cherry solutions reduce the software engineering skill set, or are we moving the problem from one skill set to another? So have I moved to a situation where I now have people who have to write really good exception handlers? Does Cherry provide a more efficient way to diagnose memory errors than the other things? And we've looked at how many things did Cherry find that the static analysis tools didn't find. They cost $2,500. They're already integrated into the build chains. We looked at how can we examine if Cherry can be directly deployed. So would you actually want to directly deploy it into these things? Or does that mean that I have got, is that giving me a problem of the fact I can't necessarily get all of the chips that I want? I can only get some of the chips or a changed, and I'm now not actually getting leading edge components for the other reasons that go with those things. And how will the solution affect what products we could offer? So if I can't get this into some of the power supply and power electronic solutions, then I won't choose it there because I need the 10% increase in range more than I need more than I need this in relation to that. So it's those sorts of things. So the social and economic benefits, particularly the economic ones, how to assess potential productivity entries. None of these things have been easy to assess, but our thing at the moment, for each of these light items, we have conclusions. Some of them are better, many of them are worse, and managing to find a way that we can answer all of those sorts of questions, I think will be important to getting to the right place. What performance overhead does Cherry generate? Particularly if we do very granular. That's a non-determinism, that we have in relation to some of those systems, trying to do non-deterministic components. Somebody looked at whether we could do a lockstep processor with one of them actually using Cherry and one of them not. That's incredibly difficult to do, because they don't behave in the same way and they're not in lockstep anymore. So it's made it a lot easier to stop these things. So these are the questions that we're working through at the moment, and I won't read them all out because you're all educated people and are quite capable of reading. And at the moment, our position in relation to this is we have found we can definitely find ways to demonstrate the benefits of Cherry in relation, effectively operating as part of a digital twin. We get none of the disbenefits and we get all of the benefits when we're trying to put it in there in that way. We have found it difficult to put it into the applications. There are just too many processes that go into that. We have found that people have already taken steps to find ways to get memory safety, to do containerization, that this is just one other way of doing that. And one of the most serious problems that we're getting at the moment is that having recognized memory safety as quite a serious thing, many of the silicon vendors have not got the same solution, but have at least got partial solutions to how you would do this that they have generated over the last 20 years. And we have to bring those on board, as it were, because otherwise they play against, which it's not for me to say, but somebody once observed to me that ARM never sell against their licensees, which is quite right. They go out of business if they did so. Thank you.
So I think we probably don't have time for questions in this session, I'm afraid, but
That's fine.
I will encourage people to come chat with you during coffee, which is waiting outside. We're very excited about this.